Okay, this is our second video in your packet on how to solve systems of equation using substitution. Okay, on our last video we talked about solving equations in terms of. Okay, so in my example down here, my first problem is solved in terms of y, because I have y equals everything else. Okay, the same is true for my second equation. Okay, this is also solved in terms of y. All right, I'm going to give you your steps to walk through and do it as an example using this problem. Okay, on your packet, you have an example that I have included for you. Okay, with each of the 4 steps kind of sectioned off so you can see and identify them. I know it's a little bit overwhelming just to look at that. It seems like a lot of work. I highly recommend you keep your work organized. Okay, it will help you a lot when you are doing these problems. Okay, neat and organized will help you not make silly errors, which could really throw you off. Okay, so when you are solving systems of equations by substitution, your first step is to find an equation that is in terms of a variable. Find an equation in terms. Okay, and you're going to substitute that you're going to substitute that in to your second equation. Okay? In this case, I could do it either way in my example because both of my equations are already set up in terms of a variable. In this case, it is y. Okay? Sometimes you might only have one that is set up in terms of, and you might be more inclined to use that one to substitute. Okay, here's what I mean when I say substitute into your second equation. If you look at our first one here, and we have y equals 2x plus 7. Okay, in my second equation, which is y equals 5x plus 4, okay, instead of saying y equals, I can say that 2x plus 7 equals, okay? Because I already know that y is the same as 2x plus 7, okay? So instead of writing y, I'm going to only have one variable that I'm solving for. So it's going to say 2x plus 7 equals 5x plus 4, okay? In this case, you do not have to do any distributing to solve this, okay? You know from here what to do. This is a multi-step equation, okay? Sometimes you might have something like 2y equals, and I would have to distribute before I can solve. Okay, that is not the case here, so don't worry about it. Okay, so your second step is to solve for your variable. Okay? In this case, I am solving for x because all I have left are x's. Okay, in 2x plus 7 equals 5x plus 4, what could be my first step? Good, let's combine like terms. Okay, remember that phrase, combining like terms? I'm going to subtract 2x from both sides to do this. Okay? And my new equation that I have from here is 7 equals 3x plus 4. Okay, to solve just for x, I'm going to move my 4 to the other side of my equal sign. Okay, when you cross your equal sign, you flip your sign. If it was positive 4x, I'm going to subtract 4. Sorry, just 4, not 4x. And my new equation is 3 equals 3x. Okay, and if I just solved for x, I could say that x equals, well, 3 divided by 3 is 1. Okay, I have just solved for my variable. I have solved for x. Okay, your third step is you are going to plug this answer back into an original equation. Okay, I need to plug in my solution to the original equation. Okay, my original equation that I started with was y equals 2x plus 7. Okay, instead of saying x, I'm now going to plug in 1. Okay, so I could say y equals 2 times 1 plus 7. Well, what is that? 2 times 1 is 2 plus 7, y equals 9. Okay, now you have solved for x and you have solved for y. Your very last step, okay, is to display your answer as an ordered pair. Okay, display your answer as an ordered pair in x comma y. Okay, the solution to my systems of equations here is 1 comma 9. This is my answer. Remember, systems of equations are just talking about the point of intersection. It wants to know the points that two lines share. Okay, on most lines it is just one point and it's displayed as an ordered pair. You did that when you were graphing. Okay, this is just the same process, except you don't have to graph this time, it's using algebra. Okay, so here we have again just this example problem that you can look at when you're going back. Remember, your first step, you have an equation that is in terms of, and since you know what y equals, instead of saying y in the second equation, you're going to substitute in what it equals, which is 5x plus 1 in this example. Okay? Once you plug it in, you're going to solve for your variable, which we saw here was x equals 2. Okay? Your third step was to plug your answer into the original equation. Okay? You plugged 2 back in for x into your original equation. And you then solved for y. Okay? Once you knew here that y equaled 9 and you saw that x equals 2, you put your solution as an ordered pair, an x comma y. Okay, those are a lot of steps to remember. I highly recommend making a little book for this quiz, okay? Those are a lot of steps. All right, so let's try another example together. I have y equals 3x minus 12 and y equals negative 2x plus 3. Okay, which one do you want to use? They're both already solved in terms of. All right, this time let's look at our second equation. I think that's a good idea. Okay, this time we know that y equals negative 2x plus 3. And we're going to plug that in over here for y. Okay, our new equation is negative 2x plus 3 equals 3x minus 12. Okay, our first step is always to combine like terms. Okay, I want my x's equal my numbers in this case. So this has an x and this has an x. How can I combine them? Okay, this is negative 2. I'm going to have to add 2 to get it to the other side of my equal sign. And my new equation is what? Well, those are going to cancel, and I have 3 equals, well, 3x plus 2x altogether, I have 5x's minus 12. Okay, again, I want to solve just for x. This is just a multi-step equation. I need to combine my numbers. Okay, well, since I have x's over here, I'm going to move my numbers to this side of my equal sign. So if it's negative 12x, I'm going to add 12 and add 12. Okay, what's your new equation? Well, those are going to cancel, and I'm left with 5x equals 3 plus 12 is 15. Okay, when you divide by your coefficient of x, you get that x equals 3. Okay, remember, we need to save that answer because it's going to be part of our final solution. Okay, now that I have x equals 3, can I plug it back into an equation? Yeah, of course we can. Okay, let's plug it back into the second equation because that's the one that we manipulated. So I'm going to say y equals negative 2 times the quantity of what? We said x is 3 plus 3. Okay, negative 2 times 3 is negative 6 plus 3. Okay, that's a skill we need to work on a little bit here, is adding a negative and a positive. We're adding a negative and a negative. Okay, in the sake of a timeline, or a number line, if I have negative 6, negative 5, negative 4, negative 3, okay, as I'm adding something to a negative number, I'm getting closer and closer and closer and closer to 0, okay? So in this case, negative 6 plus 3 is, well, 3 over here is negative 3. My y equals negative 3. Okay, if I wanted to give a solution to this system of equations, I would say for our solution that these systems of equations are going to cross at the point 3, negative 3 on a coordinate plane. All right, we have one last example that we're going to work through together before I let you loose. Okay? Which of my equations up here is solved in terms of a variable where it has 1 times that variable equals everything else? Good, it looks like our second equation here is solved in terms of x this time, okay? So if it's solved in terms of x, I need to substitute this into my second equation for x, right? I'm taking this negative 3y plus 11 and plugging it in for x. Okay, what does my new equation look like? I'm going to have 2 times the quantity. Here's where we substitute. Negative 3y plus 11 minus y equals 1. Okay, all I changed is instead of having x, I now have what x equals from my second equation. Okay, we need to distribute. Do you remember our distributing? Okay, it's going to both numbers in the parentheses. Watch their signs. Okay, 2 times negative 3y is negative 6y. 2 times positive 11 is positive 22. Minus y equals 1. Okay, combine like terms. My like terms here are negative 6y and negative 1y. Okay? A negative plus a negative is going to be getting larger. It's going to be getting further away from 0. Okay? In this case, I have negative 7y plus 22 equals 1. Okay, what's the next step that I can take here? Good, let's subtract 22 to move it to the other side of our equal sign so we can solve for y. Okay, here we have negative 7y equals 1 minus 22, or negative 22 plus 1 is negative 21. If I divide by my coefficient, I get that y equals negative 21 divided by negative 7 is positive 3. Okay, I have y equals positive 3. Let's plug this back into our original equation, okay? We're plugging it in right here for y. Our new equation, we can say that x equals negative 3 times, what's our y again? 3 plus 11, okay? Negative 3 times 3 is negative 9 plus 11. Okay, we get that x equals 2. Okay, if I know what x equals and what y equals, what is my solution? Okay, it's an ordered pair, remember? In this case it is 2, 3. Okay, go ahead and try the rest of these. There are 4 guided practice problems, I believe. Try them for tomorrow and check them with the checking packet when you get to class. Be sure that you did them correctly, okay? And fix your errors in a pen so that you know how to do it properly when you try your homework.